co-host and I,
Alright, so this video is about number 9 on your quiz study guide. We're going to look at each of these free body diagrams and explain the movement that each could possibly have. So you do need to know the difference between balanced and unbalanced forces. Balanced forces are when all the forces on the object are equal in magnitude and opposite in direction. And then unbalanced forces is when they're either not equal in magnitude or they're not opposite in direction or a combination of the two. So for the first one, A, we've got arrows pointing in all directions, and they all seem about the same length. So we're going to say this is balanced, and I'm just going to write an B next to it to represent balanced. For the free body diagram B, we've got two arrows, one up, one down. They're the same length, so same magnitude. There's nothing left or right. So this is also a balanced free body diagram. For C, we've got the same arrows going up and down, but now we've got an additional arrow to the right. We don't know what type of force this could be. It might be friction. It might be an applied force. We don't know. But because we don't have an arrow of the same magnitude going left, we've got an unbalanced. So I'm going to write a U for unbalanced. For D, it's basically C, but flipped the other way. So instead of an arrow to the right, we have an arrow to the left. So this would also be unbalanced for the same reason C was unbalanced. For E, we've got 4 arrows again, one up, one down, one left, one right. But the up and down ones are equal in magnitude and opposite in direction. So those two by themselves are balanced. And so it would be like B. But you have your left arrow is bigger than your right arrow. So that makes it unbalanced because they're not equal in magnitude. So determining if it's balanced or unbalanced is important because for A and B, if they are balanced, they are going to be at rest, so they're not moving because objects at rest will have balanced forces acting on them, or they will have a constant velocity, meaning they can be moving, but it will be at a constant rate, so there's no acceleration taking place. Now, what direction are these moving? Any direction. For A, you've got forces going every way, so it might be going constant to the right, constant to the left, constant up, or down. For B, depending on the types of forces this is, it may be moving constantly to the right or constantly to the left, or it could be going up or down. For instance, if this was a tension force and this was gravity, if they are equal, then that rope could be pulling that item up at a constant rate. If this was instead a air resistance force going up and gravity going down, it could be falling at a constant rate. So it could be any direction for both A and B. Now for C through E, we've got unbalanced forces. And again, it depends on the type of force of which way they're going. So if we're assuming that all of these are gravity going down, that's generally going to be the trend that you see. If they're sitting on something, then your up arrows would be a normal force, but again, these could be air resistance, they might be a tension force or a spring force going up. Now, these arrows to the left and to the right could be an applied force, it could be a friction force, or some other type of force involved. The main ones we're working with are applied and friction in the left and right directions. So for C, if we do have an applied force going to the right, that would mean this object could move to the right. But what if instead of applied force, it was a friction force? That means it would be going to the left, but slowing down. So this could be moving left or right. For D, it's the backwards of D is backwards of C. So if C is moving left or right, then D can also be moving left or right because they're opposites of one another. So this one C can go either way, D can go either way. Now for E, you've got arrows of different magnitudes. It's basically like D, but with a smaller arrow added in. So if the larger arrow was an applied force and this was a friction force, it means it's moving to the left, speeding up. So it can move to the left. Now if instead we put friction over here and applied over there, it could be a force being applied to the right, but friction is greater, but it could still be it could be slowing down as it goes to the right. So it could go left or right. So all of these diagrams can go left or right. The first two can also go up or down or be at rest. So any A, B, C, and D, and E can all move in the left or right direction. To really know which way you're going to go, you're going to need more information than what we're given in these basic diagrams. So I hope that explains number 9 on your study guide.